We're going to be graphing quadratic equations today. We're going to start with the function f of x equals x squared. You know this is a quadratic because the power on the x is 2. So we'll start with a table that's been already designed for you. It has the x values of -2, -1, 0, 1, and 2. What we're going to do is take those x values and plug them into f of x equals x squared. And when we plug in -2, we will get 4. So when you square a -2, you're going to get -2 times -2, giving you a positive 4. So you now have a point -2, 4. We're now going to move on to when x is -1. We're going to plug in -1 to x squared. And when we do that, we're going to get 1. So we have a second point of -1, 1. We're going to continue this by plugging in 0 to x squared and get 0. So we have another point 0, 0. And we're going to plug in 1 to x squared and get 1. So we have a point 1, 1. And then we're going to plug in 2 to x squared and get 2x squared, 2 squared, sorry, which is 4. As you notice, the parabola is graphed down below here. All quadratics, when they're graphed, are called parabolas. And parabolas are U-shaped. So as opposed to being linear like we've been doing in the past. So now we're going to graph these points, -2, 4. And we're going to come over to -2. I'm going to go 1, 2, 3, 4. And you'll put a point. So let me get a pen here. Okay, put a point. And you're going to graph -1, 1. So you're going to come over to -1 on the x and rise 1. You're going to put a point here. Then you're going to do 0, 0. And there's your point. And then you're going to do 1, 1. And then you're going to do 2, 4. And when you graph a parabola, it's not a line, it is a curve. So you're going to try to make this as curvy as possible. You're going to always extend a little bit beyond the first point or the last point that you have graphed. Come down to either the bottommost point in this case, and then swing it back up and follow that curve, avoiding straight lines, and put arrows on the end, because this will continue indefinitely in the upward direction. And that is a parabola that you have just graphed, your first quadratic equation that you've graphed. So now let's talk about our parabolas. The one we just graphed, f of x equals x squared, is called the parent parabola. All parabolas are compared to this one. Since the coefficient of the x squared term is positive, its direction is up. So here's our coefficient, which is 1, but it is a positive number, and that's all we care about. That tells you if it's going to go up. And up means this u going up looks kind of like a U, as opposed to being upside down. Every parabola has a vertex point. That point is where your parabola either stops decreasing and then turns it back up and goes and it's increasing, or the other way. Maybe it's growing and going increasing and then coming back down and decreasing. Wherever that is called your vertex. This parabola has a vertex right here at 0, 0. So I'm going to mark that vertex with a red point. That's our vertex point. Since the y equals x squared parabola turns up, this vertex point shows you that you have a minimum value. Your minimum value is based on your y, almost like a height. How high or how low did it go? So because it's turning up and our vertex is at 0, 0, this value 0 for the y is the minimum point. Every parabola has what's called a line of symmetry. Your line of symmetry shows how if you reflect one side of the parabola over this line, you'll get the same thing on the other side. So if you reflect this right-hand side over the green line, you'll get the left-hand side, and vice versa. This line of symmetry is always vertical. It's a vertical line that's drawn through the vertex. Since it's a vertical line, it's not a function, so it's an x equals, and it would be x equals 0. It's always an equation, and you get that 0 from your vertex point for x, and you write it up as x equals 0 for this particular parabola. That can change as we start to learn about parabolas that are different from f of x equals x squared. Since we're staying with the basics, we're just going to move on a little bit. Now we have f of x equals 2x squared. So just like we did before, we're going to take the values that I've given you in the table for x. We're going to substitute them into x in the equation. We're going to calculate what y is, get our points and graph. So here we go. So when we plug in negative 2 for x squared, remember you have 2 times whatever x is being squared. So it's going to be 2 times negative 2 squared. Negative 2 squared is 4, so times 2 is 8. You can take this expression as you see it right here, and you can plug it into a calculator, and it will spit out the number 8 for you, if you're doing it correctly. So make sure you put parentheses where they belong, and you put your negative signs where they belong. We have the point now, negative 2, 8. Plugging in negative 1 for x, we're going to wind up with 2 times negative 1 squared is 2. Plugging in 0, we're going to get 0. Plugging in 1, you're going to get 2. And plugging in 2, you're going to get 8. And as you notice, right now we're not adding anything to the x squared or after the x squared. So our vertex is always going to be 0, 0 when your equation looks something like this. So what you can see is you have a pattern here for y. 8, 2, you get your vertex, and then it's 2, 8. As we continue learning about parabolas and other vertices, vertex points, we're going to see the same kind of pattern on the other side of those vertex points. So let's graph this. I'm going to go to negative 2, 8. So negative 2, up 8. We're going to go over to negative 1, 2. We're going to go to 0, 0. Using symmetry, you have 1, 2. You can see the same thing on the other side here. And 2 to 8. Okay, and we're going to draw the best of our ability here, a curve, which you guys should have a easier time to draw by pencil than me, drawing with the marker here, my fingers on the touch screen. And that would be something of what your parabola should look like. Try to make it a little bit more curvy and a little less rickety in here though. And we'll be practicing those for a long time, so we got time to perfect it. As we can see, our direction is up. Our vertex is 0, 0. It's a minimum point of 0 for y. And our line of symmetry is this line that comes right down here, right through our vertex. And it's x equals 0. Another thing you're going to notice compared to the parent parabola, it's a little thinner or a little skinnier, what we call narrow. Okay, we're going to begin talking about this. Think about what you see in this equation, what might make it narrower than the original parabola. All right, moving on, we can see we've got f of x equals negative x squared. Okay, we're going to do the same thing. It becomes pretty repetitive. Just got to watch that negative sign here. So we're going to take the negative of negative 2 squared. So negative 2 squared is positive 4. We're going to take the opposite of that, negative. So it gives us negative 4. So there's our point, negative 2, negative 4. We're going to do the same thing here. That negative in front of the x squared is outside. Plugging in negative 1 and squaring it. It's going to give us positive 1, but we're going to take the opposite of that, so it gives us negative 1. 0 is unaffected, so it's 0. When we plug in a positive 1, we're going to get the opposite of that, which is negative 1. And when we plug in that should be a positive 2. Sorry, so let's make that a positive 2. That will give us a negative 4, so it gives us negative 4 here for our point. Okay, so now let's graph this. Okay, and this should be positive, so we're going to put a little positive sign here because that was an error. Okay, so we're going to come over here and we're going to go to negative 2 and up to down to negative 4. So we're here. Whoops, that's a really bad point. Let's undo that point, try that again. Okay, a little point right there. There we go. We're going to go to negative 1, negative 1. We're going to go to 0, 0. We're going to go to 1, negative 1. And we're going to go to 2, negative 4. All right, and we're going to draw our parabola. And we'll draw on this side so you can see the symmetry. Oh, that's pretty bad. Okay, now you can see our parabola is upside down. Take a look at our equation. What do you think makes it upside down as opposed to upside right? Well, it's the negative sign in front of the squared term. Okay, so the direction is down in this case. Our vertex is still 0, 0, and our line of symmetry is x equals 0. Since y equals the negative x squared parabola turns down, it has a maximum of 0 as opposed to a minimum. So the highest point here is 0. And I'm going to put a little negative sign in front of that little x there too. That should be, because that's what that equation is. All right, we're going to do one more, and it's y equals 1/4 x squared. Before you groan, because I know you don't like fractions, design the x's so that they will work out very nicely with 1/4. So same as always, we're going to plug in the x value of negative 4 into the x squared. So negative 4 squared is 16, but we're dividing it by 4. So we wind up with 4 as an answer. When we plug in negative 2 for x squared, negative 2 squared is 4, but we're dividing by 4, we're going to get 1. 0, it's out 0. And then there's a pattern, so think about it. What do you think is going to come next? Well, 1. And then next would be 4. Okay, so let's graph this guy. So we're at negative 4, positive 4. So we're here. We're at negative 2, 1. We're at 0, 0. Using symmetry, you can see you're at negative 2, and you're at 1 again. And then you're at 4, and 4. And when you draw this parabola again, you extend a little bit past where you were. Draw it as neatly as you can. Swing it around, back up. Put arrows on the end, of course, because it continues indefinitely in the upward direction. And this one looks a little wider than the original parabola of x squared. What do you think is making that happen? Okay, things we're going to discuss when we get back together. So write those answers down. What do you think is making this wider than the y equals x squared? Now you notice our direction's up, our vertex is 0, 0, and our line of symmetry is x equals 0. And this does have a minimum point of y equals 0. So we just put, when it has a minimum or max, we just put the number, not an equation. And that is how you graph very basic parabolas. And that is just the start of what we're going to be doing. You have a homework assignment of 2 problems. You should write out your calculations as we have shown here in your tables that are provided, and you graph your parabola. If it comes out looking zigzaggy or linear, something is terribly wrong. It should look like a U, upside down or right side up. And this concludes our lesson on how to graph quadratic equations.